In this video, I'll introduce the basics of word representations. I'll talk a bit about different representation forms, and then introduce context, co-occurrence, and vector space. This will in turn provide the framework for learning about some of the specific representation techniques in the next few videos. There are a lot of different ways to represent the meaning of a word. Two classic strategies include bag of words representations and logical representations. We already learned about bag of words representations in this course. In a bag of words representation, you basically say, here's my entire vocabulary, and I'm going to go ahead and represent it as a vector with an index for each word in the vocabulary. And then I'll put either a 1 or the frequency count in the indices corresponding to words in my text sample, but leave the other indices all blank. In a logical representation, you basically just say, here's a word, and it's a symbol that defines its own meaning. So the realization of the word dog is directly attached to some symbolic representation lurking around somewhere. The latter representation isn't very useful in natural language processing, but the former has been quite popular because it turns out to be a surprisingly effective way to represent meaning as it is needed for common NLP tasks. A bag of words representations are a somewhat rudimentary implementation of vector semantics. We saw in the introductory text that vector semantics follows the distributional hypothesis, which states that a word is defined by its environment or its distribution in language use. In natural language processing, we define environment as the set of contexts, or neighboring words or grammatical constructs, in which a word occurs. Two words with very similar sets of contexts are assumed to also have similar meanings. In a bag of words representation, this would mean that two texts that included the same or nearly the same collection of words, albeit in any order, would be assumed to be highly similar to one another. We actually do this ourselves all the time, and the textbook provides a nice case example of this. Let's say, for example, that you've never heard of the word ong choy, which is also sometimes referred to as water spinach and is found in a lot of Asian cuisines. However, you're reading some cooking blogs, and you see a bunch of sentences like these. Although you've never seen the word ong choy before, you've seen the other words in those contexts plenty of times in sentences like these. Because of that, you can probably pretty confidently conclude that ong choy is probably some kind of leafy green, similar to spinach or something like that. So a big goal of ours in natural language processing is to come up with clever ways to allow computers to perform the same kind of reasoning. A simple way that we could conceivably do that is by saying, okay, let's define context as the 3 words before and the 3 words after. And let's look at all the words that occur in the context of ong choy in our large corpus, and then let's see what other words occur in those same contexts. So we can represent these contexts using vectors. In vector semantics, we define each word as a single vector point in an n-dimensional semantic space. So for a bag of words representation, n would correspond to vocabulary size. The different dimensions in each word's vector representation correspond to different aspects of its meaning. In a bag of words representation, for example, the value stored in a given dimension would correspond to the presence of a context word C in close proximity, so in whatever context window we defined, to our target word W. Assuming that our vector representations do a good job at reflecting real semantic relationships, we should be able to then cluster those vectors into different semantic groups. For example, maybe we come up with clusters of words associated with writing and with holidays. We should also be able to perform operations on the vector representations of words that end up being semantically intuitive. For example, maybe we find that adding together the vectors associated with the words summary and analysis ends up producing a vector that is extremely similar to the vector associated with critique. Word representations are an extremely important component of natural language processing, and there are increasingly sophisticated ways to compute them. I'll talk about some of these in the next few videos.